So, as a part of this talk, we are going to talk about what is EDA architecture. I'm sure you already know what is EDA and what are the benefits of EDA, but we'll go through some of these slides very fast, and then we'll focus more on the use cases of Solace plus AWS and how Solace and AWS are helping our customers to implement EDA architecture. So yeah, we have seen this in our last reInvent as well. EDA is mainstream, and as you can see, we have like so many people trying and implementing EDA architecture here, right? And events are everywhere. Now, this is a very important slide, and we have seen the same slide in the today's keynote as well. And as you can see in this slide, the value of the data is like really important when you process it in the early on in near real-time basis. Right? But then if you do it like after a lot of latency, the value goes down, right? And that's why the EDA is like extremely important from the processing and getting the value from the data. Now, this is a typical example that we have put here. Like this is a store example, and as a part of this, what we want to highlight is if you do it something in a batch processing and if you do it in a real-time mode, what are the benefits of it? And as you can see here, we have one customer who bought the last item available on the store. Right? Now, if any other customers are going, they won't be able to buy this particular item because it is not yet available on the store, right? Because of the batch processing, because of the non-real-time nature of the integration, the warehouse was not able to send this item to the store. Right? So, and that means any other new customers who are trying to buy this item, they won't be able to buy this item. Right? Similarly, if you have any web portal where customers can go and buy these items, since the inventories are not yet synced up with the real inventory, if customer who is trying to buy it online, they won't be able to buy it because inventory is not available. And if they by chance go to the store to buy this item, they won't be able to find these items. And again, this will result into customer dissatisfaction. And lastly, if you have any loyalty programs or anything else, customers won't be able to see the real loyalty or points accumulated because again, the inventory and the loyalty programs and everything is not yet synced up properly. Now, even if you do with the API integration, right? You can still take care of the real-time integration perspective, but then you will end up in making more like a very tightly coupled system. Now, when you have EDA, you can generate events in such a way that before even inventory is going down, and you can generate event and make sure that the warehouse is able to get this inventory and put it in the store. So that means you will always have some sales going on irrespective of the total inventory count. Right? Similarly, if you have any web portal will have the real inventory always synced up, and you will be able to get the inventories and items on the time. And lastly, same is with any loyalty programs or any third-party integration you have. You can generate these events and make sure that these items and inventory and sale and transaction, all of them are synced up. So as you can see here, there are some business benefits of it. When you are non-EDA environment, you will have the customer dissatisfaction, you will have some loss of sale and other things. While when you are in EDA, you will be able to increase the sales and you will have better customer satisfaction. Right? Now, what I mentioned are more of a business benefit of it, but here, as you can see, there are some technical benefits as well. Right? So one is when you have EDA, you will have a better scalability. Right? Why better scalability? Because now you don't have to think about like whether loyalty system will need the same kind of scalability and another system. Right? You can have the different scalability. If say loyalty program is going down because of some reason, you will always have something else which is available as well. Right? So you have better resiliency, you will have better scalability, and then you will also have better cost as well, right? Because now you don't have to provision the hardware in the same way. And when you have tightly coupled system, you need to make sure that all your transactions and all inventory and your risk management system as well as loyalty, all of them have like highly available and the better or the higher hardware, right? And lastly, it will also have a reduced complexity because now you are modularizing, you are creating small components, and then you are designing systems according to that. So this will have a better complexity as well as the cost perspective. Now, this is a typical journey that we have seen in the customer's environment when they are moving from, say, non-EDA environment to EDA environment. We have seen that first you need to identify the domains, and when I say domain in the sense, it can be like an order management can be a domain, or risk management or risk system can be a domain, or inventory can be a domain. Right? So once you identify domain, you need to think about designing events. And in next couple of slides, we will see how to design events basically and what are the ways of designing events. And then you think about what is the broker or what kind of broker you need. And there are some criteria that you need to choose select the broker based on those kind of criteria. And finally, you start building the actual system. Now, yeah, so this is the way you design a particular event, right? And as you can see, it's a different kind of mindset. Right? So when you are an API integration way, right? So where you have like synchronous APIs exposed, you think more from the customer or the consumer point of view. You are thinking like saying, yeah, I want to get the status of an order, or I want status of a payment, or I want to understand what is happening to the car. Right? So that means you are thinking more from the subscriber, more from the consumer point of view. But when you are in EDA architecture, it's a different mindset, different ways of thinking, where you think more from the publisher perspective. Say you are an order management system, you think that, yeah, I'm order management system, I'm going to publish the events related to order, right? And consumer might be interested into that, right? Sometimes it is possible that you may not have any consumer, but then that's how you think, your thinking changes from the consumer to the publisher perspective. Right? Now, typically, in any event-driven architecture, you will have an object, right? So where the order can be an object, or car can be an object, or payment can be an object, right? And then you will have some actions associated with that, right? So it can be like a car stopped, or payment initiated, or payment failed, or order fulfilled, right? So that's an action. And finally, you have some metadata associated with that, and that is a very important part of the event, where metadata can be like version 1 of the event can be a metadata, or an event originated from a particular region, right? Or that can be a metadata. A date can be a metadata, right? Or a type of the transaction can also be a metadata as well. And in the next slide, we'll see some examples associated with it. Right? So here, as you can see, this is a typical example of an event, and on the red color, what you see is the payment name. So that's an object. So here you are saying payment is an object, and then init is an initialization of it. So what we are saying is payment is initiated. So that's a kind of event that you have. Right? And what you see back in the red, yellow color is all about the metadata. And here you are saying V1 is a version 1 of the event, right? And then you are saying, yeah, UPI is the payment methodology. So this event is related to UPI, which is a payment, not related to credit card, not related to say net banking and credit card and debit card, but it's related to UPI payment. And then you have some taxi, which is for the taxi company, and Ola, right? So this is like really important metadata from the filtering, for the applying rules, routing, and other thing perspective. Right? Now let's see an example of it. As I mentioned previously, for one publisher or one type of the event, you can have multiple types of the consumer. Right? Some consumer might be interested into all the kinds of payments. Right? Some consumer might be interested only in like payment initiation. Some consumer might be interested only into like UPI type of the payment, right? And as you can see here, right? Sorry. Right? So as you can see here is we have the first subscriber, and where we have the payment initialization, and that customer or the consumer will get all the payments related to the payment initialization. Similarly, the next example, what you see is the star UPI, right? And here what you are saying is this particular subscriber will get all the events related to UPI payment, right? Irrespective of whether it is for payment creation, payment failed, or some other types of the payment. Right? So here, I mean, this is how you can apply like filtering. This is how you can apply a lot of rules associated with it. Right? Now here, there are like a couple of other examples in a similar way, where you can see that we have account and we have account related things. But then, yeah, this is how you do the filtering, and metadata can be used. Right? Now, metadata can also be used for various routing purposes as well. I mean, you can route the messages to a different consumers, different regions based on this kind of metadata. So in short, yeah, I mean, in any event, you will have some object, some verb, or some action associated with it, and then metadata associated with it. Now, let's see the typical components in EDA. So one is you'll need to have a publisher who will be responsible for publishing this kind of data. And then you have a consumer. I mean, you may have a consumer, you may not have a consumer. Sometimes you have like no consumer, because you have just started publishing this data and events, and there are not yet consumers. Sometimes you may have hundreds of consumers consuming the same types of event. And it is quite possible that consumer may not even know who is the publisher is, right? And that's where the broker becomes like really important, where broker will get these events from the producer, will apply some transformation, some rules on top of it, and give it to any consumers. And in next slide, we'll go through what are some important criteria for selecting a particular broker. Right? So in this slide, what you can see is like some functional as well as some non-functional criteria for selecting an event. Right? So as you can see, it can be related to compliance, where you are saying, yeah, I need a guaranteed delivery because it is part of the compliance. Right? or it can be like a high volume or high latency kind of. I mean, take an example of any capital market or banking and other industry where you have like sometimes sub-millisecond requirement to process this event or get this event. So that can be like one of the important criteria for selecting an event broker. And then you have like some non-functional criteria as well, like your architecture as well. I mean, you might be a very global large company, and you may have some workload running on-prem, some workload running on, say, US East 1, something running in EMEA, and now you want to join or have a hybrid architecture, right? Or it's possible that you are in the process of migration, where you have a lot of workload running on-prem, and you are in the process of migrating that workload on AWS, and you want to have a broker which will allow you to seamlessly migrate these applications on your on-prem to the AWS environment. So this can be like another like important criteria to select the broker. Secondly, when you have like very large enterprise, you may have like hundreds of publishers and thousands of subscribers. Right? In that scenario, you want to have some way where subscriber can see, what are the different types of the events I have? Like what is the catalog of the event? Right? What are the attributes of an event? Right? And what are the different ways events can be processed? What is the metadata associated with? And that's where you need to have some sort of event portal or mechanism by which you can see that entire enterprise level, what are the different type of messages and events you have it. Right? Lastly, I mean, you may also have a lot of requirement to dynamically apply a lot of filtering and rules and configurations as well. So that can be like another factor for deciding the broker. Okay. Now, this is the typical architecture mainly for the Solace environment, where you have the customer will have a deployment in say region 1, region 2, region 3. These are multiple regions. Customer might be using multiple AWS services as well, right? And they may have sometime SQS, some Lambda, some S3 buckets, and etc. And they may also have some workload running on-prem as well. And that's where you can have the Solace, which can integrate, which can allow you to pass these events across the entire regions and global regions. Right? Now, in next few slides, Mike is going to help you understand what are the different case studies and joint customer implementation we have done. We'll go through some of the case studies, the hybrid architecture, and we'll also help you understand how we have helped our customers to migrate and create this entire global hybrid architecture. Okay. Nice. Thank you.
Okay. Thank you. So my name is Mike Hilmen. I'm the Director of Technology for our partnership organization. I'm dressed this way because I was stranded in Dallas last night. I literally got off an Uber about 10 minutes ago. Didn't have my bags, I had nothing. I was stuck in Dallas. We've all been there, right? We've all been there. So I never check a bag. How many of you guys check your bag? No one does, right? Because it's ridiculous. And the first time in 10 years, I checked my bag, and I'll never check it again. Okay. So with that, okay, so first we're going to start off, I want to talk a little bit, so we're going to talk about how Solace and AWS provide this global event backbone, right? And the advantages that Solace bring. You guys know about AWS, that's kind of why you're here. I want to introduce you to Solace and how we work together. So first off, what is Solace? We are an event platform, and we're composed of 3 components. We have our broker that provides the routing and the brokering. We can mesh those together, and we'll talk about that a lot, into what we call an event mesh. And then we can manage all of this, and we can observe all of this. And all of those kinds of tools are based in the AWS environment. Okay, an event mesh. The event mesh provides some pretty unique capabilities and differentiators, and they really enhance what you can do with your AWS implementations. Probably the most important one would be getting data to AWS. That's a challenge sometimes, either from on-prem or from other clouds. And the event mesh concept makes it very easy for customers to take data, to take implementations, and move them to the AWS cloud easily. And we'll talk about some particular use cases where that's used. And I'm going to use some notes here too while I talk. Okay. I want to touch on the form factors real quick. So when you deploy Solace, You deploy the broker for Solace. There's 3 form factors. There's a hardware appliance, there's software, and then there's a SaaS. And obviously the SaaS is what you leverage in AWS. And I'm bringing this up because it's relevant for some of the use cases so you have the context. The important thing to take away is the ability to form an event mesh isn't curtailed by the form factor that you select. We have all kinds of customers that use some hardware, some SaaS, and some software all over the place, and they make a nice, big, happy mesh. There are, however, scale differences, which you can see on the screen. And then, most importantly, we are tightly integrated with AWS. So we have 12 connectors at the moment. If you count in, bidirectional capabilities, there's support for S3, Kinesis, Gateway, SQS, SNS, and MSK. We also have RESTful support for Lambda, and we just released a beta version of the Event Bridge connectivity, and I'm hoping to actually be able to demo that at reInvent. And then, shouldn't say hoping, I'll be able to do that. So if you want to see it, come by the booth, we'll have it. And then things like AppFlow, right? Firehose, X-Ray, Redshift, they're in varying degrees of kind of requirements gathering, research to determine how we can work with those as well. All right, so enough on the Solace product. Let's talk about what we can do. And I'm gonna have to have my notes here just a little bit, guys, I apologize. What we can do. So we'll start with Macquarie Bank. So Macquarie Bank, it's a large customer for both Solace and for AWS. What they had was, in maybe around 2013, they built an event platform, and this was based almost entirely on Solace hardware appliances, and it worked really well. It could handle 8 billion messages a month, no message loss, worldwide distribution of data, but it didn't align with their internal goal of 100% cloud adoption by the year 2022. And so you couple that with the fact that the appliances they had on-prem were reaching the end of life, they ended up with a 11-month window to migrate to the cloud. Given that, the first choice they had to make was which broker to use. So they looked at all the brokers. There's some cloud-native stuff. There's other third-party things. There's all kinds of brokers that are available. And they decided to go with Solace for a few reasons. One was the fact that they had a history with Solace. The other one was the fact that it supported some of their key requirements around reliability, requirements of the event mesh, and things like multi-region, multi-cloud, that kind of stuff. All right, so they moved ahead with that. They ended up putting together a migration plan over 9 months. And probably the most important benefit they realized right away was that they didn't have to go through the typical lift and shift. Because of the way the event mesh works, and because of the way the event mesh supports hybrid connectivity, what they could do is they could take a module at a time of on-premises capabilities and move that to the cloud. So they move a piece to the cloud and then go ahead and run in production, right? Move another piece to the cloud, test, run in production. And the capability to communicate real time between on-premises legacy information and cloud-based information was there, and it was provided again by the Solace event mesh. So that was one of the first benefits that they realized, and the ability to make that migration easy. They're now 100% cloud. They adopted things like infrastructure as code, using automation to drive CloudFormation templates to push this stuff into the cloud. And then, IAC continues to yield dividends for these guys. They can do things like optimizing when certain systems go down, when certain systems come back up. So it's pretty robust. And then they noticed a few other benefits too. One of those was going full cloud. Systems that used to be geographically separate, a little bit distant, were now under the same cloud umbrella. And so they've gotten a number of benefits from that. One of those would be reduced network latency, as expected. So the overall time responsiveness is down. They have minimized ingress and egress costs because they've centralized where things happen. They're not as frequently coming into and out of the cloud. And then a simplified security configuration, again, because most of the stuff's in a single AWS VPC. And the last benefit that they've really found there is this concept of adaptability and agility. One of the problems that they had with the hardware solution was the hardware appliance is vertically scaled higher So you can do more with a single appliance. So what they ended up doing was putting multiple lines of business on the same physical appliance. And what that does is it limits when you can take it offline. So the FAA, so they have this NAS, National Airspace System. It's based on this concept called SWIM. SWIM is the system-wide information management system, and that's based on Solace. They kicked off a project maybe about 10 years ago. They noticed that they needed to have more agility and more capacity in their handling of data, and they did some grunt work, figured out which would be the best solution, and they ended up selecting Solace for that. So Solace provides now, if you ever check in your phone for the status of your plane, noticing that your flight is canceled when you land in Dallas, that all comes via Solace, and it's been a good project for them. Let's see here. So again, they surveyed lots of different cloud products for this and third-party products for this, and they discovered that Solace would be, from the concept of a fully redundant and global network-based capacity, Solace would be the best option there. And then they selected AWS as their cloud service. And they did the on-premises stuff first, built out the fault-tolerant network, and then slowly but surely they're putting stuff into the cloud via a solution called SCDS. It's a software cloud distribution service, and again, that's based on AWS. And their capacity to go to and from the AWS services is facilitated by that tight Solace AWS integration. Some pretty good benefits from this. They estimate that the next gen project on the whole has generated more than $2.5 billion in benefits by the end of 2016. By the end of 2020, that number jumped to over $13 billion in cumulative benefits. So it's been a very successful journey for the FAA. Okay, so United Airlines. As probably most airlines, they have an objective of becoming the world's best airline, right? The ability to move their real-time data across their enterprise and across the different geographical locations is, of course, essential to that, right? And with an eye on AWS, they're implementing this vision via a hybrid cloud initiative. There's a lot of on-premises stuff they still have. So they ordered something like 700 new aircraft, right? They're going to create as many 50,000 new jobs. It's going to result in more destinations, more passengers, more employees, right? More baggage, more data. And getting this data where it needs to be is crucial, right? And where it needs to be securely and accurately and in order is crucial to its success. They also had some concerns around things like resilience, potential data loss, and data ordering. And so with those in mind, they came across or started this multi-year digital transformation plan to move from legacy applications to the cloud, right? And they had another requirement as well. What they didn't want to have happen is they couldn't have the efforts to modernize conflict with existing projects and future projects that still had to go on. So it all had to interwork together, right? They had to support the legacy systems and facilitate getting off the legacy systems while not disrupting any of the current production systems. And then, of course, as you can expect, millions of producers and millions of consumers of data. So they ended up creating this project with these kind of defined requirements. Well, number one, cross-region replication with zero message loss, 100% in-order delivery of all messages under any failure and routing conditions across both their highly available and their disaster recovery systems. They had to replace their existing message-oriented middleware, again, running both as distributed and as mainframe in that case. And rapid time to market was key. JMS compliance was also key, along with support for REST. And I apologize, I keep moving this mic away. Can you guys still hear me? You can hear me okay? All right, good. Security was key. So data at rest, data in transit has to be secured with SOC 2 compliance, right? Effective hybrid cloud and multi-cloud capabilities to ease the migration from cloud to on-prem. They needed support for SWIM standards, and yes, this is the same SWIM standard I talked about a slide ago with the FAA that's based on Solace. So that was, of course, helpful in their selection of Solace to meet these demands. Runtime observability, so maximum visibility of events. As the events are created, as they're cataloged, right, and as they're moving across the system, traceability. And as I mentioned, so they picked Solace, and the initial project, the initial POC was a baggage claim POC. Three regions were involved on premises, and then 2 AWS cloud regions. And they're seeing great success with this today. They're getting cross-cloud region data replication, again with 100% in-order delivery and 0 data loss. They're seeing improvements around management, observability, right, and it even fits into their DevOps toolchain. So big success there. And then my last example here is going to be Standard Charter. So Standard Charter, for those of you who don't know, 86,000 employees, right, and a presence in 60 countries. They serve customers in close to 150 different markets worldwide, revenue over 15 billion. Their focus is in corporate investment and retail banking. In 2012, Standard Charter, they rebuilt their enterprise service bus across their retail and their wholesale parts of their bank, not with Solace. And there was some success, but unfortunately they did experience some pain, specifically around things like disaster recovery, reliability, some message loss. And the end-to-end tracking of data wasn't where they needed it to be. So this presented an opportunity led by the CIO to kind of rethink their data transformation initiatives and to overhaul the system. So, and they wanted to have their developers to have the ability to actually begin creating applications on their own. At the time, there were issues with the middleware team in which if you wanted to create a new application, you had to connect with the central team, you had to communicate what you wanted, the data you wanted, you had to spin up some instance of the middleware, and then that would service you, and that could take days, weeks, sometimes even months. So it was a big blocker for agility. So they wanted that addressed as well. At the same time, they had different initiatives around new cloud projects, right? Big data projects, and this aligned very well with their initiative around the digital overhaul. They onboarded a couple new customers, very bursty traffic patterns, very dynamic flows that had to be accounted for as well, and some pretty significant increase in scale. So by 2016, they had become a customer of Solace, and they reached out to us to discuss some of these new requirements and how we could help. And we obviously said we could. They ended up selecting Solace as the core of this kind of next generation event bus within Standard Charter. And the reasons for this are, again, around things like concerns for performance, resilience, scale, and agility. So this prompted their next shift in their architectural style. They had started on message-oriented middleware, which is point-to-point, it's queues. They'd shifted to service-oriented architecture, SOA, and then this final or this latest, I should say, they're not done, right? This latest move is to EDA. And as they've made those progressions, they're gaining more granularity, more granular access to data, more flexibility as they shift. And they're also being able to more greatly decouple the consumers from the producers. A consumer in a MOM environment has to know where to get their data from, right? What queue am I going to read this from? Whereas you move all the way to EDA, now the consumer can be completely oblivious of who creates the data that they're consuming. So they moved forward with the project. Their EDA adoption involved 3 core capabilities. The first one is the event mesh. As I've talked about, they had a desire to move data across their global enterprise dynamically with some agility and with some real-time resilience. And the next was taxonomy. Now, this is the event model that Chintan mentioned earlier in the presentation. And as he shared, it's a way of describing your events, right, in this ephemeral and completely dynamic way, which is used for the basis of routing your events across this event mesh. And I'll talk about this a little more later as well. The key for the use case story is that it's this aspect of Solace that provides probably the most value for Standard Charter because it gives them this concept of agility. right? They can now begin adding new, not just new services, but whole new applications, whole new capabilities, and get access to the data that they need almost immediately by simply making a subscription. So a good example would be, all high-value trades out of Singapore need to be run through this, this audit system or something like that. And in order for them to solve that problem previously, they have to go to all the payments handlers and tell them, look, we need to have these types of data sent to this new endpoint. With Solace now in place, all they have to do is create the application or set of services in the application, subscribe to that data, and they immediately get it. And there's no effect to anything that's running in place at the time, and the access to the data is effectively real time. And the last piece for them is the event catalog. So for them, it's just a glossary of events that allow you to create and design them. It allows you to govern the events, and then it allows you to track their utilization in real time. And that, of course, maps to what we call our event portal. Okay, so that's it for my stories. Now, but I usually get our questions, and so how does this work, right? What actually is working here? We'll start with kind of a review of the foundation that I've been talking about. So the capabilities that Solace brings in the context of these hybrid scenarios, right? Number one is topic filtering. And as I mentioned, a topic describes the event, and it's metadata, right? It's just a flag or a tag on the event. It's very different from what many other brokers describe as a topic, right? And this is the whole differentiation between implementation, right, and interface definition. We can do all kinds of pattern matching, support for wildcards. It's very, very robust, very granular in its capabilities, and it runs the dynamic routing capability that we talk about. Now, this is what is used by the event mesh to get data wherever it needs to go. And again, the event mesh is just a set of brokers. It can be 2, it can be 20. The brokers are deployed in the locations where you either produce or consume data. You connect them together. This is a fairly easy task. You can do it graphically. We can show you at the booth outside. It takes about a minute, and then you hit go. And then the capabilities to communicate with other systems like Kafka or IBM MQ, file systems, databases, et cetera, are all native within the product. And then the event portal capability. So again, this is about, now I've got this mesh that lets me take data everywhere. I've got these topics that tell my data where to go, and subscriptions. Now I need to, of course, govern this and manage all of this. And that's what the event portal does. And it manages the events. It gives you real-time updates on the health of the system, visualizes things and such, right, and provides governance. And then in the middle of all this concept of distributed trace, right? So it's one thing to understand what events can I use and how do I use them. It's quite another to say, this event was sent and application B is telling me they didn't get it. Why not? What happened, right? So distributed trace facilitates that type of mean time to innocence, as they say. Okay, so those are the main capabilities. I'm going to go through these slides pretty quick. So what are the manifestations of this? Number one, single pane of glass management. This runs in AWS, right? And this, as it suggests, provides mission control. How do I provision the data? How do I make my event mesh? Insights, how do I monitor the event mesh? And then the event portal, how do I define new events? How do I find events that already exist? How do I access them? And how do I govern them? The event broker is obviously a key piece of technology. It is the heart of the runtime, and it supports things, as we've mentioned, dynamic routing, but also things like message replay, right? Different patterns, streaming, queuing, request reply. Slow consumer handling. Is anybody here familiar with slow consumer handling? Okay, in the context of distributing persistent data to more than one consumer, slow consumer handling basically means I've got 5 entities that want this data. They all want it in a guaranteed fashion, where the order is guaranteed, and one of them goes down. So I'm giving all the data in real time to these 5. I got to keep all the data ready for the 5th one for when they come back online. And then when they come back online, I need to be able to feed data to that 5th one faster than everybody else so they can get caught up. And in the context of all that, not have my performance degrade. 2 or 3 or 4 consumers, that's not so hard. 100, 200, 2,000 consumers, that becomes more of a challenge. WAN optimization, we talked about things like hybrid cloud. When you're moving across the cloud, the capacity to optimize that WAN channel becomes essential. And then things like high availability and security. We're in 85% of the global investment banks. We're in lots of government entities. The security is all there. And if you have any questions on how the security works, how granular the security is, we can talk to all that at the booth as well. Just suffice it to say it's there, it's granular, and it performs. Okay, so support for open source and open standards is key. AMQP, right? JMS, MQTT, REST, WebSockets. These are all natively supported by the broker, and patterns like fan out, fan in, point-to-point, request, reply, streaming, et cetera. So it's very robust in how it can share data. And then the last piece here we'll talk about is protocol support. So again, support for not just open standards, but things like any programmatic language you'd want, any scripting language that you'd want, and the ability to bridge between these dynamically without having to configure anything. So this is stuff that's always on. You can pull data in via REST, send it out via MQTT, JMS, and C# if you want. And that's all handled by the broker in real time, anytime you need it. The magic of the system, right, the true value of the system lies in the event mesh. When you create an event mesh, this is, if you want to, again, if you want to come to the booth, we can show you this in a little more detail. But what you do is you deploy a node in any location that you need data. It could be cloud, it could be on-prem, it could be private cloud, it could be a public instance in the cloud, a private VPC in the cloud, doesn't matter. And then you bridge these together, and as you bridge these together, we call this the event mesh. But the event mesh is intelligent in how it routes data. It only sends data where it needs to go. So in other words, I could have something on-prem publishing data via JMS into this mesh, and as long as no one wants it, then it can be effectively discarded, right? No one cares about what the data is. But once an entity anywhere expresses interest in that via a subscription, then the data flows to that location, and only that data, and only to that location. And it's only the subset of data that meets the requirements as well. So you're not doing the endpoint doesn't do any filtering or routing. And likewise, you can have new consumers in new regions or new clouds express interest to the same data. They can express interest to new data. And all that data bidirectionally can be exchanged and shared across any protocol that you want. And this is all, again, it's dynamic, it's optimized, it's highly performant, it's highly secure, and guaranteed not to lose any data. The smart topics, like as I mentioned, it's the topic design that facilitates the power of the routing within the context of the mesh. So I'll go through this real quick. When you start thinking about designing a topic, you want to basically specify the taxonomy first. So in this case, at the very top line, there's a source, right? There's data, there's a material type, maybe the sales org, maybe the plant, et cetera, some details about the data. And then you've got enumeration, potentially enumerated values of those, right? So what kind of materials, if it's basic, if it's sales data, if it's plastic, if it's metal, those kind of details there. And then from the specification of that taxonomy, you can then begin creating subscriptions to the data that you want. So this first line here up top, I want materials, basically associated with sales. It's metal, it's high tech, and it's, item number 199. I want that specific, or in this case, sales org for plant 199. I want that specific set of data. Or you can begin inserting wildcards. So you could say, I want all materials that are basic. I don't care if it's metal or plastic or anything else, give me everything. I don't care if it's high tech, low tech, or anything else, give me everything. But I only want it for plant 200. And vice versa, you can keep going down. And then the wildcard with the greater than sign is saying, I want materials associated with sales. And the wildcard says, from here on down, I don't care what it is, give me everything. So again, it's a very robust way of specifying what data that you want to have access to. And when we talk about things like how Standard Charter has the ability to be significantly more flexible in how they create new applications, this is what it's based Okay, and then the event management. So for those who are familiar with APIs, API gateways, the maturation of the capability of the API management came from the fact that at first you've got an API gateway, and maybe it's fronting old SOA services with RESTful interfaces. And over time, they decided they want to expose these services not just to internal lines of business, but externally as well. And that requires some level of a gateway, or of enhanced gateway, I should say, but also a portal that's going to allow for people to come in to catalog and document what APIs are available. Can I discover what assets I can use? I can share and reuse things, right? I can analyze, extend, and design my capabilities, even generate code. And the RESTful-based API management capabilities are pretty well defined now. On the event-driven side, we're still a little immature. So the concept of a broker is there, and the broker does what we expect. It connects publishers to subscribers, right, given different protocols. But what we're missing still is the ability to define or have a place to go, a portal to go to, that still facilitates the cataloging, the discovery, the governance, the reuse, and the sharing of those assets. And that's what the event management capability in Solace brings to bear. And then I'll end on the product piece here. It's secure, right? And we can talk about security in depth if you'd like. I don't want to go into it in too much detail here. Just know again that we have a number of customers that have put us through the ringer in terms of security, and so it's been vetted. We are super excited to be partnering with AWS. We've had a lot of great traction up through the last, say, year and a half. You know, we're part of the Accelerate program. We're part of the VMAP co-marketing program, and we're on the marketplace as well if you want to take a look at the product. And the last slide I think I have here is about our community. So the Solace developer community, which is run by Tamimi, who I think is in the back. No, he's not. He's gone right now. But he's here. He told me to say, join the community and you'll get swag. All right. Thanks for your time.